André-Marie Ampère made the revolutionary discovery that a wire carrying electric current can attract or repel another wire next to it that's also carrying electric current. The attraction is magnetic, but no magnets are necessary for the effect to be seen. He went on to formulate Ampere's law of electromagnetism and produced the best definition of electric current of his time.
Electric current is the flow of electric charge through a conductor. Here, the charge is in state. This flow must be with electric current.
Ampere also proposed the existence of a particle we now recognize as the electron, discovered the chemical element fluorine, and grouped elements by their properties over half a century before Dmitry Mendeleev produced his periodic table. The SI unit of electric current, the ampere, is named in his honor. Beginnings. André-Marie Ampère was born into a well-to-do family in the city of Lyon, France, on January 20, 1775. His father was Jean-Jacques Ampère, a businessman. His mother was Jean-Antoinette de Soudières-Sarcy, the orphan daughter of a silk merchant. André-Marie's parents already had a daughter, Antoinette, born 2 years before André-Marie. It was an intellectually exciting period in French history. Antoine Lavoisier was revolutionizing chemistry, and Voltaire and Jean-Jacques Rousseau, the leaders of the French Enlightenment, were urging that society should be founded on science, logic, and reason rather than the religious teachings of the Catholic Church. When André-Marie was 5 years old, his family moved to a country estate near the village of Polemieu, about 6 miles, 10 kilometers, from Lyon. His father had grown so wealthy that he no longer needed to spend much time in the city.
She's so small, Mother.
A second daughter, Josephine, was born when André-Marie was 8.
She has a whole family to
An unusual education. The education André-Marie received was rather unusual. His father was a great admirer of Jean-Jacques Rousseau, one of the leaders of the French Enlightenment.
Father, is it true that all
He decided to follow Rousseau's approach for André-Marie's education. This meant no formal lessons.
The books will show you.
André-Marie could do as he pleased, learning about anything he felt like. He was also allowed to read anything he wanted to from his father's large library. A recipe for disaster, you may think. In fact,
this one glows.
It calls and it worked exceptionally well.
Secrets of knowledge
André-Marie developed an insatiable thirst for knowledge, going as far as learning entire pages of an encyclopedia by heart. Although a child of the French Enlightenment, André-Marie did not reject the Church, and he remained a practicing Catholic throughout his life. My father never required me to study anything, but he knew how to inspire in me a great desire for knowledge. Before learning to read, my greatest pleasure was to listen to passages from Buffon's Natural History. I constantly requested him to read me the history of animals and birds. Mathematics. Age 13, André-Marie began a serious study of mathematics using books in his father's library. He submitted a paper about conic sections to the Academy of Lyon, but it was rejected. The rejection spurred him into working harder than ever. His father bought him specialist books to help him improve. He also took his son into Lyon, where Abbé Dauberon gave him lessons in calculus, the first formal lessons André-Marie ever had. Physics. Having taken his son for formal mathematics lessons, his father also took him to Lyons College to attend some physics lectures, which resulted in André-Marie beginning to read physics books as well as mathematics books. Revolution followed by tragedies. Life so far had been peaceful and enjoyable for André-Marie, but a period of tragedy was beginning to unfold. In 1789, when André-Marie was 14, the French Revolution began. In 1791, while André-Marie continued his home studies on their country estate, the revolutionaries gave his father the legal role of Justice of the Peace. In 1792, André-Marie's older sister Antoinette died.
André, she is at peace now.
In 1793,
But I am
the
not.
Jacobin faction
How
of
can I
the
go on?
revolution
We will carry
guillotined
her
his
memory
father.
together.
The great chemist Antoine Lavoisier was guillotined by revolutionaries in 1794. Mercifully, André-Marie, studying mathematics and science on the family estate, survived the revolution's reign of terror. He was devastated by his father's death and abandoned his studies for a year. Ampere's lifetime in context. Becoming a mathematician and scientist. In late 1797, age 22, André-Marie Ampère opened up shop as a private mathematics tutor in Lyon. He proved to be an excellent tutor, and soon students were flocking to him for help. His tutoring work came to the attention of Lyon's intellectuals, who were impressed by Ampere's knowledge and his enthusiasm. In 1802, he became a school teacher in the town of Bourg, 40 miles, 60 kilometers, from Lyon. A year later he returned to Lyon to work in another teaching position. In 1804, he moved to the French capital, Paris, tutoring university-level classes at the École Polytechnique. His work impressed other mathematicians so much that he was promoted to full professor of mathematics in 1809, despite having no formal qualifications. André-Marie Ampere's contributions to science, electromagnetism and electrodynamics. In 1800, while Ampere worked as a private tutor in Lyon, Alessandro Volta had invented the electric battery. One result of this was that for the first time ever, scientists could produce a steady electric current. In April 1820, Hans Christian Ørsted discovered that a flow of electric current in a wire could deflect a nearby magnetic compass needle. Ørsted had discovered a link between electricity and magnetism, electromagnetism. In September 1820, François Arago demonstrated Ørsted's electromagnetic effect to France's scientific elite at the French Academy in Paris. Ampere was present, having been elected to the Academy in 1814. Ampere was fascinated by Ørsted's discovery and decided he would try to understand why electric current produced a magnetic effect.
Watch the needle, it's moving.
Ampere began by repeating Ørsted's work, and before the end of September 1820, had made a discovery of his own. He found that if electric current flows in the same direction in two nearby parallel wires, the wires attract one another. If electric currents flow in opposite directions, the wires repel one another. Ampere had discovered something amazing. He had produced magnetic attraction and repulsion in the complete absence of any magnets. All of the magnetism was generated electrically. He called this new field electrodynamics. Today, electrodynamics and electromagnetism are regarded as the same field.
A revolution in science.
No magnets here, the current itself creates the force. The field surrounds the wire.
Ampere's
This
law.
is electrodynamics, it will change
Ampere
everything.
then brilliantly found an equation connecting the size of a magnetic field to the electric current that produces it. This equation, known as Ampere's circuital law, is highly mathematical, requiring university-level mathematics to use and understand. It is shown below in differential form relating the magnetic field, V, to the current density, J. This equation applies to situations where the electric current is constant. Over 40 years later, James Clerk Maxwell modified this equation so it would also apply to situations in which the current is not constant. In this form it became one of his four famous equations establishing that light is an electromagnetic wave. The electron. To explain the relationship between electricity and magnetism, Ampere proposed the existence of a new particle responsible for both of these phenomena, the electrodynamic molecule, a microscopic charged particle we can think of as a prototype of the electron. Ampere correctly believed that huge numbers of these electrodynamic molecules were moving in electric conductors, causing electric and magnetic phenomena. Discovery of fluorine. Ampere did not restrict his interests to mathematics and physics. They were wide-ranging and included philosophy and astronomy. He was particularly interested in chemistry. In fact, preceding his work in electromagnetism, he made significant contributions to chemistry. Ampere discovered and named the element fluorine. In 1810, he proposed that the compound we now call hydrogen fluoride consisted of hydrogen and a new element. The new element had similar properties to chlorine, he said. He and Humphrey Davy, who was British, entered into correspondence, even though France and Britain were at war. Ampere proposed that fluorine could be isolated by electrolysis, which Davy had previously used to discover elements such as sodium and potassium. It was only in 1886 that French chemist Henri Moissan finally isolated fluorine. He achieved this using electrolysis, the method Ampere had recommended. Organizing the chemical elements. In 1816, 53 years before Dmitry Mendeleev published his periodic table, Ampere proposed that the chemical elements 48 were known at that time, should be grouped according to their properties. He made a number of mistakes but successfully grouped. The alkali metals, sodium and potassium. The alkali earth metals, magnesium, calcium, strontium, and barium. The halogens, chlorine, fluorine, and iodine. He was also moving in the right direction by identifying similarities in the noble metals, rhodium, palladium, iridium, platinum, and gold. Unfortunately, Ampere excluded silver from this group. First series transition elements: iron, cobalt, nickel, copper, although uranium was incorrectly included. Transition elements: niobium, molybdenum, chromium, and tungsten. Ampere did not name the groups as they are named above, such as the noble metals and transition elements. These are modern names. Mendeleev had an advantage over Ampere in that 65 elements were known to him, allowing him to see patterns more easily. Importantly, Mendeleev also paid attention to atomic weights, while Ampere did not. To be fair to Ampere, we need to remember that J.J. Berzelius published the first reasonably accurate list of atomic weights in 1828, 12 years after Ampere's elements were. The ampere. The SI unit for electric current is the ampere or amp, symbol A, named in Ampere's honor. It was Ampere who first defined electric current as a circulation of electric fluid in a closed circuit. Some personal details in the end. In 1799, aged 24, Ampere married 25-year-old Catherine Antoinette Caron, who was usually called Julie. A year later, their son Jean-Jacques was born. He was named in memory of Ampere's beloved father. Tragedy struck Ampere when, after less than 4 years of marriage, Julie died in 1803 of abdominal cancer. Ampere got married again in 1806, to Jean-Françoise Patat. The couple quickly realized their marriage had been a mistake. Their daughter Albine was born in 1807, and the couple legally separated in 1808. Albine came to live with her father and his younger sister Josephine. In 1824, Ampere was appointed to the chair of experimental physics at the Collège de France in Paris, which he occupied for the rest of his life. Ampere's son, Jean-Jacques, became a notable professor of linguistics and a member of the French Academy. He and his father were known to have rather explosive arguments with one another, both having quick tempers. At the age of 61, Ampere caught pneumonia. He died in the French Mediterranean city of Marseille on June 10, 1836.
Come, let's have some tea.
He was buried in Marseille, but his remains were later moved to the Montmartre cemetery in Paris. Many other illustrious people are buried in Montmartre cemetery, including the composers Hector Berlioz and Jacques Offenbach, the artist Edgar Degas, the author Émile Zola, the physicist Léon Foucault, the mathematician Stanislas Ulam, and Ampere's son, Jean-Jacques, who is buried next to his father.